All right, and we are live. So today, last week I did a live stream on building a multi-data center fabric with Arista AVD, which runs on top of Ansible. And we actually built the fabrics in both data centers, but we don't have a DCI between them. And if you see on the screen here, so this is our topology. So we've got 3 spines in each data center. We've got 4 leaves in each data center, 2 hosts in each data center, and a pair of border leaves connected through a DCI router. All these devices are EOS, so we're going to use AVD to control them and configure them, with the exception of the host, which we manually configure because when we're doing any kind of automation, even if as a networking team, we're going to use Ansible, or we might use Ansible to do our automation. A server team also might use Ansible, but they're going to run them separately. So that's why we're configuring the host manually. They're going to be configured probably with a different Ansible setup. So, and we'll just do them manually because there's only 4 of them. And one thing we didn't do is we actually didn't test it. And now I did some spot checks. I checked to see that if we had EVPN sessions between the leaves and the spines, and we did. And we can go in. The environment is shut down and it started back up again. Oh, I also I put all the put everything in a GitHub repository. So let me get that URL real quick. If you want to take a look at what this is, it's on my personal. I'll put it in the chat room. I'll put it in the notes a little bit later as well. So there's the chat. All right, there it is. So Tony Burke is my B-O-U-R-K-E. Tony Burke is my personal GitHub repo or GitHub account. So one of the things we didn't do is we didn't actually test, and we couldn't. We can't right now because in each data center we have 2 hosts that are on 2 different tenants, so they actually can't connect to each other. And for red to connect to red, we have to go through the DCI. So what we're going to do real quick is I'm just going to test one data center. I'm going to move this onto red for now, and just to make sure that I can actually pass traffic inside the data center. This is a virtual environment. However, all of these EOS devices, they are full data plane and control plane. There's a few things that don't work in the virtualized EOS environment. For example, QoS settings, because there's no hardware queues. But otherwise, mostly everything works, including EVPN as a data plane and control plane. So we're going to go to host 2 DC1. And oops, didn't mean to do that. Set this up here, just so I don't have to type in Arista. So I'll do host 2 DC1. I don't think I actually configure this, or I forgot to save the config. Probably I forgot to save the config. Mode active, IP address 10.1.20, what was it, 11? Yeah. Oh yeah, port channel 1, no switch port. No IP address. And then we'll do a static route as well. IP route 10.1.10.0. 121, and I'll go ahead and open up a new shell and log into host 1 DC1. See what we got going on there. We do have that IP address in there. Can we ping our default gateway? Yeah, we can. I do have to change 2 files. Actually, no, I don't. I only have to change the connection. So, and I just have to move this to port to VLAN 20. And so it's an access port. So this will be VLAN 10. We'll go ahead and label it. VLAN 10, and VLAN 20. Now I had to put a static route in because the hosts actually already have a default gateway, a default route, and that's for something else for the lab environment. So I'm just going to show IP route. Make sure that we have that in there. Yep, I do have that in there. So when I change one of these files, this is one of the benefits of using AVD and Ansible in general, is I'm not going to go into the leaves or spines and make any config changes. I'm just going to change the file. So I changed this one thing here, host to DC1, which is plugged into leaf 3 and leaf 4 on Ethernet 6 and 7. And I just changed it from VLAN 100 to VLAN 20. That's all I needed to do on the fabric side for the config change. And then I will run the playbook to build the fabric. So right now it's going to go through, it's reading all of these files, and it's doing a total config replacement for these configurations. Now there's two ways to push these configs. We can push them directly to the EOS devices, or we can push them through CloudVision, which is Arista's automation platform. We can use it as a total automation platform, or we're using it in conjunction. So what CloudVision is doing, let's go ahead and log into CloudVision here. So in CloudVision, every device's configuration is made from these things called configlets. And configlets are discrete pieces of configuration. So where's everything? Okay, there they are. So if we go into leaf 1 is comprised of a couple of configlets. And every time I make a change, I build the configuration. So now I've got brand new config files. And you can see that it only changed leaf 4 and leaf 3 in DC1. The others, the files were unchanged. Then I'm going to deploy. So what it's going to do is going to take those configlets, those new configlets, and do a replacement of the configlet. So this configlet here will change. It'll be completely replaced by the new version of that file that CloudVision generates. Now, if I was doing directly to EOS without going through CloudVision, then I would need to build a config that's the entire config for the device. But because the configlets have, because the devices have a number of configlets like ATD infra and then the base configlet, which has things like the management address and some other stuff, I can just, I only need to update the part of the config that it involves EVPN VXLAN. All right, so we've got two new configlets uploaded. We're going to create a change control just like we normally do. That's the other benefit. That's, there's several benefits of running through CloudVision. One, it's got a really nice built-in change control system, so I can review the change before it's executed. I've got a configuration warning, but that's just port fast, letting us know that we shouldn't plug another switch into that. Now, technically we are, but they're pretending to be hosts, so they're not going to behave. They're not going to send BPDUs, etc. And it also does some configuration validation to make sure that the configuration on the device is going to work. If it doesn't, it'll kick back an error, and then we'd have to figure it out. All right, so we're making that change there. It's going through, and then now we can, on host 2, I should be able to ping 10.1, 10.11, and I can. So it does work. So I'm going to change this back to 100 and do that process again to get it back in line with our diagram here. So this is going to be blue. And this will be VLAN 100. So this is multi-tenant IRB, integrated routing and bridging. The IPs can overlap between the tenants, but we're not going to have them we're not going to have them overlap because it'll get confusing. And the tenants don't have the tenants and their VRFs don't have access to each other unless we either route leak or go through like an external firewall or an external router. And we're not going to do that here. So we're just going to keep them isolated from each other. So I'm just going to assume it's going to work over here in DC2. We'll find out soon enough anyway. So we've got the fabric built in every data center, but we don't have a DCI built. And now we've got a couple of choices. So I'm going to make a copy here so we can use it as kind of a scratch pad. So what we're going to do is we at least need to have the underlay between border leaf 1 and 2 in DC1 and border leaf 1 and 2 in DC2. We need to have them peering with DCI. We could redistribute other routes, but I think we're just going to stick with BGP. As you can see, I gave it an AS number, so we'll put that on there. And so we'll at least redistribute the loopback routes from each data center to the other data centers. And at that point, we have a choice. We could, in terms of our EVPN routes, we have to share them between our spines. Now, we could do EVPN peering with the DCI and have it act as a route server. So that's one option. In that case, the DCI would have all of the BGP routes, all the type 2 routes, type 3 routes, type 5 routes, whatever type of routes we have for EVPN. It wouldn't install the routes. We don't need to worry about our forwarding tables because we're not actually going to install them. We're just propagating them. So we could do that through DCI. It might be beneficial to have it in the DCI so we can do some show commands there. The other option is to just have the DCI be the underlay. And do I have... That would be like a two-way. I'll just do one of these. So the spines would peer with each other. So let's make that nice and thick. So the EVPN sessions would just have every spine would peer with the other spines. So there's a couple ways we could go about doing it, and they all, honestly, I'm not sure which one is the best. We're going to go ahead and just peer with the DCI. And we're going to make that, well, let's get the underlay built and then we'll make the decision later. I honestly haven't, I've done it one way and I know pretty sure I can do it the other way. I think we'll do it the other way, but we'll see. So let's go ahead and... So we've got the files created. We've got DC1 YAML, which has our DC1 configurations. We've got our DC2, which has our DC2. So it's got our spines and our leafs, and they're in node groups, which are MLAG pairs, because we're going to run them in MLAG. And each one of them has their own VTEP address space. So this is the loopback 0 pool 101. This is the loopback 0 pool in data center 2. It's 201. So we're just using the first octet to encode which data center we're in. And of course, if we have more than 2 data centers, we're going to have to figure something else out after that. But so now we need to configure our DCI. Now we also have a couple of choices. Because it's just one switch, I could just go in and manually configure it. I don't have to, if you wanted to just manually config DCI and just go in by the CLI, bang out a quick configuration, I certainly would understand why you would want to do that and not put it into this automation. But we're going to go ahead and try to do the automation on it. We're going to actually try to have AVD actually do configuration for DCI. So what we're going to do is we're going to put DCI into our inventory file. I don't think it's in there right now. So for Ansible to do anything, for AVD to do anything, it's got to be an inventory. And Under fabric, I'm going to do, oh yeah, it is, yeah, we did put it in there. Okay, so it's under there. So we've got it under there. And then I've got DCI YAML. I can, see, what do I want to do? There's a couple of ways we can do this. We can treat it like a super spine, and we can get the peering going. We can treat it like a spine and get the peering going, even though it's not really a spine. Or we can just kind of do a manual configuration, or not kind of. And what we're going to do is we're going to use a structured config. So what AVD is doing is we're using a role called EOS designs, and it takes all this information in our group vars and looks at each device that we have defined, and then it generates an individual structured config, a YAML config, and then another module, another role rather, called CLI config-gen will take the structured config that was generated from EOS designs and then generates a actual EOS syntax file. So what we're going to do is we're going to skip the design step, at least on the DCI part, and we're going to create a new directory, and it's going to be called host vars. And this is where you put files that you want to be, or you put attributes you want to be applied directly to a device rather than a group config, a fabric config, etc. So we're going to do that, and we're going to create DCI.YAML. And this is going to be our DCI config, and the baseline configuration is already there, so we don't have to worry too much about all the different parameters because the management's already there. The management interface is already configured in a different configlet. But if we were going directly to EOS, I'd have to put all that in here. I'd have to put the management, DNS, NTP, user accounts, all that stuff in there. But they're already on there through a configlet through CloudVision. So I just have to put the particulars in here that are going to be specific to the DCI. And let's figure that out. And we'll have to do it for the border leafs as well, because we're going to need to create these interfaces. So I'm going to create a new actually, no, I think we can do, yeah, let's try this instead. We'll leave that there for now. Under fabric, there's a couple ways we can do things in all of this, and I'm not sure which one's the best. I know which ones I've tried. So let's go ahead and do it like I did in my multi-DC fabric. Oh, that's my multi-pod fabric. All right, so we have the option to do what's called an L3 edge that we're going to define in the fabric on both sides. And we're going to need a links IP pool so we can auto assign some IP addresses, so I don't have to go through and like I'm going to have to assign an IP address to DC1, DC2, and then DCI on those two interfaces, and same thing over here. So a lot of /31s, and I'm lazy, so DCI gateway. Let's do 192.168.90. Pull it from that. Peer-to-peer links. And this is going to be a list. Again, I will. This will be uploaded into the repo. Got one viewer. Nice. It's probably showing up on everyone's recommended, and they're just kind of like, oh, what's going on? So if you're one of my skydiving viewers, this is definitely not skydiving. But if you're one of the networking people that follow me, this might be of interest to you. So what we're doing is we're building a fabric based on AVD, which is a project that runs on top of Ansible for Arista EVPN. I'm reading off notes, by the way. So DCI gateways are a pool. Our nodes are going to be border leaf 1, DC1, and then DCI. So this just allows us to configure both sides. And we have to specify the interfaces. And I happen to know, I have it memorized, but just go to border leaf 1, DC1, and then show LDP neighbors. And DCI is connected on Ethernet 12. So this will be Ethernet 12 on border leaf 1. And on DCI, I actually don't remember which one that, I think it's Ethernet 1. And show LDP neighbors, and yeah, it's Ethernet 1. So we're not going to do the not going to do host vars right now, so we'll just do it this way. We'll see what happens. We do have to specify our AS numbers, 65199 on border leaf 1, and then 6500. The second link. The pool is really nice because I don't have to like open up Excel and start assigning IP addresses that way. So this would be border leaf 2, DCI. The interfaces will be Ethernet 12 on border leaf 2 and Ethernet 2. And then our AS numbers, same thing, 65199, 65100. So in case you're wondering where I get this from, I got it from the AVD website. So it's avd.sh, and it's under reference designs, EOS designs. We go to role variables. And we look in the, change the menus a little bit. And we're looking at fabric. Yeah, DCI and edge. So this is where we set these different parameters. We could set things like PTP, QS profiles, MACsec profiles, etc., but we don't need any of that. ID 3. This is just the individual links using the gateway pool. We could specify the IP addresses if we wanted to, but I don't really want to. So DC2 connecting to DCI. Interfaces is Ethernet 12. It's Ethernet 12 on all the border leafs, which is nice. This one will be Ethernet 3. Our goal here is to at least, our goal here is just to have the underlay in one DC redistributed to the underlay of the other DC. We need to make sure that the loopbacks in DC1 are accessible in DC2 and vice versa. So this is $299 because this is DC2. And I think for the rest of the second one, we're just going to cut and paste, but you always have to be careful when you cut and paste that you don't forget to change a value. I think we're good. So let's go ahead and generate that config, and let's see if we get the underlay joined, because that's what we're going for. We want to join the underlay right now, and we'll worry about the overlay later. So we're going to build the fabric again, and what we're looking for on border leaf 1, DC1, we'll just do a spot check and see if we have a new Ethernet interface created in the EOS syntax that we'll later upload into CloudVision. All right, should be spitting it out now. And there it is. So now we do have an IP address from the 90 subnet, which is, so it's auto-assigning the IP addresses for us, that's one of my favorite things about AVD is I don't have to worry about assigning those /32s. All right, so let's go ahead and deploy it, and then we'll see if we get we'll deploy it, and we shall see if we get the underlay redistributed. That's what we're going for. I wonder what's changing leaf 4. What's changing on leaf 4? Oh yeah, we changed it back to the old VLAN. Okay. All right, so we did our border leafs. Didn't configure DCI. Unless, yeah, I think I know why. We gotta wait for it to finish off. Yeah, it hasn't applied the. Oh yeah, under configs we have not created a DCI, so why not DCI? Something I'm missing here. Oh yeah, I guess we want to do it this way. I'm just going to make it a super spine. So our DCI config here for the fabric, for the group vars. I think I might actually be able to make it a spine. Let's just do super spine. And loop back. Nope. I don't think I actually need this. And then, yeah. Nodes. DCI ID 1. Management IP address. '76. All right, let's try that again. Build the fabric. Should build a DCI config. There's another way we can do this too. I might try that a little bit later. But let's just get this thing up and running. My only concern with this, the way we're doing it right now is it's not technically a super spine. So if the data models change in the future, it may not create a working config. That's my only concern. Because we're not using it exactly the way it was meant to be used. Because a super spine is supposed to join two pods together in a DC instead of two data centers together. But it generates the correct configs. All right, so yeah, it still didn't generate a DCI config. I did have it in my inventory. Children, there it is. Did I have the wrong? 76, 75. Which one is it? I think I might have the wrong IP in there. It's 76, so I got that wrong. There, and oh, because I didn't like this. When things don't go exactly to plan. Oh, it's super underscore. That's why. Should put that in there as well. Typo. Garbage in, garbage out. It's one of the downfalls of this type of automation. Ansible does not like hyphens in key value pairs. They like underscores. Let's see what we got. Still did not generate DCI. I'm going to delete host vars. Maybe I was thinking that was overwriting it. Nope, still doesn't look like it found it. Check my... Something's not triggering this to get generated, the DCI config. I'm just looking at my notes here. See what I've missed. I'm just going to copy and paste from my notes, make sure I didn't miss anything. Add some BGP defaults. That shouldn't matter for this, though. So build the configs. Nope, still not triggering. Got a lot of deprecation warnings. It's just warning that the purple. That's not the cause of this. It's just warning that one of the modules that it's using is being deprecated and to use a different module. It's being updated in an AVD. It's not a critical thing. Make sure I got my L3 edge right. If this doesn't work, I've got another approach I can take. I've got it to work before. Okay, I'm going to replace this with... Ah, yes, that's why. Because I forgot include an underlay routing protocol. All right, we'll use our original. This is not something I've done a ton of. So still getting used to it. The DCI is not something I haven't done a ton of. I built fabrics with AVD quite a bit, but the DCI stuff is still relatively new. All right, still not seeing it. Oops, I did see something. So change border leaf 1. So we should have some new neighbor peer. IPv4 underlay. That'll be in the 90. Yep, there it is. Just did not generate DCI's config, and I don't know why. Look at my playbook. Build fabric. Nope, that's fabric. Fabric. DCI. Check my cheat sheet again. All right, let's just cut and paste from my previous example. This is a different IP range, but I don't think that'll matter, but I'll just leave it there. It doesn't. It's all non-routed or non-public. Still did not generate a DCI config. All right, one more try and then we'll punt and try the other method. But I did get this to work before. Famous last words in a demo. So DCI. Let's rename this DCI 1. It didn't like the fact that it was the group number. And the group and the host name was the same. It was complaining about that. I don't think that'll cause a problem, but we might as well go ahead and try it. Nope. Still not generating it. Maybe, let's try this. If you can route servers, DCI1. So in this case, we're just going ahead and and have DCI be the actual route server between the two data centers. So DC1 and DC2 will both have EVPN peering with DCI. That might be necessary for this to work the way I'm trying to make it work. I think this might be a consequence of me doing it using DCI as a super spine when it's not really meant to be a super spine. So we might have to try a different method to be a little bit more proper. Oh yeah, that's in there already. Oh, we should actually do this. So this is DC1. This is DC_1 _1. Because they're just peering. Heck, damn it. All right, we'll do it a different way. This is probably a better way to do it because, again, the DCI is not really a super spine. That's kind of what I was trying to make it do. I thought I could get it to work, but apparently not. So let's go into all right, we're going to manually assign these IP addresses. So I'm going to go into DCI. And I'm going to clean that out entirely because it's not doing anything. We're going to remove these. So we won't have DCI be the EVPN server, route server. And we'll get rid of this. Because we're going to do it a little bit more manually. All right, so we're going to create the host vars again. And we're going to create a file for border leaf 1, DC1. Oops, rename that to YAML. Border leaf 2, DC1. Border leaf 1, DC2. Border leaf 2, DC2, YAML. Did I change it in here? Yes, I did. Oh, you know what? That's not going to work because that's what it's named. It was complaining about it, but I don't think it's causing any problems. Make sure I got all references out. Okay, I think we're good. So the way that we can these are the structured configs. And the way it works is on border leaf Ethernet interface. Up here is, it's actually, oh, this is for border leaf 1. Ethernet 12, that's the DCI. On Ethernet 1, peer type. DCI. Make that 1550. My address will be 99.0. And on DCI, it'll be 99.1. And we just do this same thing over here. Just cut and paste. Peer interface 2. So 0 and 1. This will be 2. Copy. Paste 3. So this is a abstracted way to configure these interfaces. .99.3. Let's go ahead and do them all at the same time. This is what I was hoping to avoid, because I don't like doing this. I don't like assigning IP addresses. Border leaf 1, DC2. So 3 and 4. This will be 5, 6. One more. The whole point about this thing was to avoid doing this type of stuff as much as possible. Border leaf 2, DC2. Okay. And then we just have to have one on here. Already did that one. Ethernet 3. 1, 2, 0, 1, 2, 3, 4, 5, 6, and 7. Or 7 and 8. This is what, yeah, I hate this. 0, 1, 0 and 1, 2 and 3, 4 and 5. I got the numbering wrong. 6 and 7. All right, that's what it is. 4 and 5. 6 and 7. So this will be 6. 4, 3, 0, 2, 3, 4. Yeah. Okay, that looks good. I think I want to do something else as well. Under my group vars. Yeah, I want to do something here called under fabric custom structured config prefix. So that way it'll create a different configlet. So my DCI. So I need to put this in front of these under my host vars. Just keeps things separate. See if that works. All right, still not building out DCI. So there's obviously something very simple that I'm missing. It's not even it is creating the DCI container. It's not creating that. Inventory has DCI. Vars, super spine, hosts, DCI. 7.6. See if I can trigger some type of... It's going to be a wrong config, but I'm just trying to do something. Just messing around, trying to get a fabric build going. It is completely ignoring DCI. Even in host vars, it should generate a config, a structured config, and it's not. DCI, multiple host. All right, I'm gonna try something. So I have another repo. Called Playground. Got one called multi-DC, and that's got my group vars, and it's got my DCI in here as a super spine. Got my inventory file. This is what I've been using for my notes. Just got to fix that. I think my thing might be wrong. My inventory file. Password for this environment, because I think it was done on a different one. Yep. We're going to build fabric, see what it does. No, it did it. Yeah, it's building DCI. So why isn't the other one? So that's the working one, and then this one's the non-working one. Oh, freaking YAML. That's why. No, I'm sorry, it was the other way around. I had it at the wrong indentation. Type super spine. Yep, that's what it was. All right, let's go back. Well, if you sat through all this, I applaud you. This is a stupid mistake. I think I might just delete this. Delete this whole thing because yeah, I'm going to start over. This should not have taken an hour, just me. You know what? I'm not going to delete this. I'm going to make a new one, and this one's going to be the blooper reel. Because in case anyone wants to see what it's like, sometimes when you're going through Ansible config files, sometimes this is what happens. I'm sure you've done this if you've been trying to troubleshoot something in networking. You know, if you can't get a BGP peer to come up and you can't figure out why, and it's just one little thing you missed, or you know, one was an I or I was a one, you know, neighbor statement or something like that. So yeah, I'm gonna save this, make it a blooper reel. I'm gonna re-record it as a new part 2. So yeah, that was embarrassing.